Velocity time graph. First of all, what is velocity? Velocity is a speed of an object in a particular direction. For examples, two cars traveling at the same speed but in different directions have different velocities. Second, two escalators are going the same speed but they are going in different directions, so they each have a different velocity. Velocity time graph is used to show the speed and direction an object travels over a specific period of time. It also called speed time graph. Horizontal axis is used to show time from the start of movement, while vertical y-axis is used to show velocity of object.
Analysis of velocity time graph. So the graph is divided into 5 sections: L1, L2, L3, L4, and L5. So for L1, which is from 0 to 50 seconds, the gradient of the line is 0, which means the bicycle is moving to the right with uniform velocity of 10 meters per second. For L2, which is from 50 to 70 seconds, the gradient of the line is 0.25. The bicycle is moving to the right with uniform acceleration of 0.25 meters per second. For L3, which is 70 to 100 seconds, the gradient of the line is negative 0.5. The velocity of the bicycle gradually decreases. The bicycle accelerates at negative 0.5 meters per second, which is in the opposite direction to its motion, to the left, which means it is slowing down.
For L4, which is 100 to 120 seconds, the gradient of the line is 0. The velocity of the bicycle is 0 meter per second, which means the bicycle has stopped. For L5, which is 120 to 150 seconds, the gradient of the line is negative 0.3. The velocity of the bicycle gradually increases. The bicycle accelerates at negative 0.3 meter per second, which is in the same direction as its motion to the left.
Determining distance. Distance traveled can be determined by calculating the total area of the regions under the line on the graph. For L1, 0 to 50 seconds, 10 meters times 50 seconds equals 500 meters. For L2, 50 to 70 seconds, 10 meters times 20 seconds plus 1/2 times 20 seconds times 5 meters equals 200 plus 50 equals 250 meters. For L3, 70 to 100 seconds, 1/2 times 30 seconds times 15 meters equals 225 meters. For L4, 100 to 120 seconds, bicycle is not moving, 0 distance traveled. For L5, 120 to 150 seconds, 1/2 times 30 seconds times 9 meters equals 135 meters. So, the total distance traveled is 500 plus 250 plus 225 plus 0 plus 135 equals 1,110 meters.
Next, determining displacement. Displacement is also calculated by finding the area under the line in the graph. Example, displacement to the right, L1 plus L2 plus L3. So, it should be 500 plus 250 plus 225 equals to 975 meter. For displacement to the left, L5 equal to 135 meter. So the total displacement is 975 plus negative 135 equals to 840 meter to the right.
Determining velocity. Velocity in a velocity time graph is represented by the vertical y-axis. Average velocity can be calculated by dividing the total displacement by the change in time. For example, finding the average velocity of L3, 225 divided by 30 seconds is 7.5 meter per second.
Lastly, determining acceleration. Acceleration can be found by dividing the change of velocity in a given period of time, which is in meter per second, by the change of time in that same period, in seconds. This also applies to average acceleration. The steeper the line, the greater the acceleration of the object. If a line sloping downwards with a negative gradient, it represents an object with a constant deceleration, which means the object is slowing down. For example, finding the average acceleration of L2 from figure 2.21, as you can see. So, acceleration is change in velocity divided by time taken, which means 5 meter per second divided by 20 seconds will result in 0.25 meter per second.